Does anyone have an extra copy of the notes for Cheyenne? Look around. Extra copy of the notes. Oh. I have 2 extra copies. One is for Emily, one is for Cheyenne. Here you go, Cheyenne. All right, so today's date is Tuesday, December 3rd. We're at 9/12/3/2019. We're on Properties of Exponents today. Who can read our objective for the day? Ella reads first.
Use the properties of exponents to simplify rational exponents.
Thank you, and it is nice for you to be back again. We missed you. So this is a review from Algebra 1 now. All of these properties are a review, and now we're applying them to rational exponents, which means I'm doing all this, but now with fractions. All of our laptops should now be shut also. We should all be paying attention. So anything to the power of 0 is always what with a quiet raised hand? Anything. I don't care what this x is. Anything to the power of 0 is always what? India.
1.
It is indeed 1. So give yourself a few examples. Please don't just always copy my examples. You can copy my first one if you want. But I have 2 to the power of 0, that's equal to 1. If I have x, let's choose a different variable. If I have y to the power of 0, that's equal to 1. If I have, in parentheses, a, b, c to the power of 0, that is equal to 1. Anything to the power of 0 is always, always 1, unless you're talking about weird calculus stuff where you have the indeterminate form 0 to the power of 0, but that's weird. We're not talking about that yet. Again, the way that we deal with education is we teach you lies and then talk about why we lied to you. So, x to the power of negative n. Does anyone know this one? How do I get rid of a negative exponent? Has to deal with the numerator and denominator. Who knows this one with a quiet raised hand? Does anyone want to take a shot at it? Colby?
X to the 1 over n?
You're really, really close.
X over n.
Try again.
I don't know.
1 over x to the power of
N?
There it is, yes. We'll give him the 50 XP, thank you. This one has another rule that's kind of like it looks very similar, and I'll write this off to the side, which is this. If I have something that looks like 1 over x to the negative n, I can get rid of the negative exponent by bringing it to the numerator and making it x to the power of positive n. So the general idea for this rule is if I flip-flop between the top and the bottom, just add a negative. It doesn't matter what letter. It changes from an n to an n. It goes from a negative to a positive, though. Or it can go backwards, forwards. It doesn't really matter. So here's a few examples that you can kind of copy. If I have 1 over 2 to the negative 3, that's equal to 2 to the positive 3. If I have 1 over AB, all of that to the negative 1, that's equal to just AB. If I have BC to the negative 1, that's equal to B over C. The exponent only applies to the C in that case, since there's no exponent for the B. The B had to be left behind in the numerator. All right, let's try another rule. If I have x to the power of n, and I can zoom in here now, x to the power of n times x to the power of m. Anyone know this rule? It's going to be x to the power of something. Who has their card? Anna, yeah.
X to the power of n times n.
You're really, really close. Other operation, not times, but
N plus m.
yeah, there it is. N plus m. Whenever I multiply similar bases, I add their exponents. So to give you a few examples, I can do something like 2 to the power of 3 times 2 to the power of 1, that's equal to 2 to the power of 4. If I have 8 to the power of 1/3 times 8 to the power of 4/3, that's equal to 8 to the power of 5/3. You're just adding their exponents. So make your own example. Show that you know that you're just adding the exponents. And our next rule. If I now divide instead of multiply, what's going to happen with the powers with a quiet raised hand? Again, looking for someone that has a card first for a priority. but we have some backups. I saw India and Eller's hand for a backup. Beverly, go for it.
Subtract.
So x to the power of,
N minus
it is indeed n minus m. I subtract the powers. So give yourself a few examples. So I can have something like a to the power of 3 divided by a to the power of 7, and that's equal to a to the power of negative 4. 3 minus 7 is negative 4. I could have z to the power of 13 over z to the power of 1, and that's equal to z to the power of 12. An even trickier example I can think of. Let's move this over so I can have some more room. Let's think of a really tricky example. I could do ab to the 7th divided by a squared b to the 3rd, and that would equal a to the negative 1, b to the 4. I can subtract twice. 1 minus 2 is negative 1, 7 minus 3 is 4. You can do it at the same time. All right, we talked about this rule yesterday, so I know that you guys have reviewed it. If I have a power to the power, what am I really doing? It's going to be x to the power of what? Quiet raised hand. Ellery.
It's going to be x to the power of n times n.
It is indeed n times m for that power. Thank you. You multiply those powers. So give yourself a few examples. If I have, let's do a to the power of 3, all of that to the power of 4, that's equal to a to the power of 12. Who is it?
Ooh, oh, was that supposed
Normally not. Oh, what's up? Okay.
to get him? Yeah, looks like my then. Because he stole it from.
All right, thank you for interrupting, Gio. I'll talk to you later. Next we have something like, I don't know, b to the power of 1/4 to the power of 3, and that will be b to the power of 3/4.
Just no.
Yes, Jane.
I have a question about this math related, don't worry.
All right.
You know how like when we were doing the thing yesterday, is there like a, like say you don't have numbers but you were just an example, is there like, are they labeled like x and n?
They are not labeled
But like
that.
because I saw an example and it said that it was like instead of numbers it was letters. It's just math, doesn't matter.
Yeah, this is the general case, so it doesn't matter what number goes in there. You can fill in a number, say like, oh, that was 3 and that was 2, and then that means I'm doing 3 times 2. It just
So,
helps
like,
you
the
set
n's
it up.
always going to be on the top.
Say again?
Or is that just the way it's written? The n's always going to be on the top. The n
No,
is-
it will not. So this is just a general case. I could have made this m on the top and n on the bottom. It doesn't matter. But then it would change this formula over here to m minus n. All right, these last two, I'm going to write a note over here that says distribute. These two right here, you can make like a little curly brace. I kind of think of these as the distribute rules. You kind of distribute the power inside. So anyone want to take a shot at this one? X times y on the inside, all of that to the power of n. India?
It's gonna be n to the power x to the power of n and y to the power of n.
There it is. Both of those have a power of n. Give yourself at least one example, if not more. So if I have, this is a really good example. I think everyone should have something similar. 2y to the power of 3 is equal to 2 to the power of 3, y to the power of 3, which means it's really equal to 8y cubed. Everyone have something very similar to this example because this is the most made mistake when it comes to this rule. You see a number and you think, oh, I don't have to worry about the number. No, the number has to have a power along with the variable. So that means if I have something like, let's choose, I'm going to do another number problem, like 1/2 times b squared. All of that to the power of 2 is going to be 1/2 to the power of 2, and I ran out of room there, b to the power of 2.
I have a question.
Yes, Jaden.
2 questions. Is this going to be separated into different things, or is it going to be all one thing?
trying to remember. I guess I can go and look at our unit
You
guide.
don't have to go look. It's not a big deal. But second question: Is there anybody staying after school today to like teach or stuff?
No one is staying after school today. No. I'll be here until about 4:30ish. Today we have 2 homework assignments. And finally, this rule. Who wants to take a shot at it? Anna?
X to the power of n minus over y to the power of n.
Yep, there it is. Again, you kind of just apply that power to the inside. So I'm just going to do one example because we're now running a little bit short on time. I didn't realize how long we were taking here. So if I have something like 1/2 all that to the power of 3, that's equal to 1 to the power of 3 divided by 2 to the power of 3, which means I'm really doing 1 divided by 8. All right, so we're going to have lots and lots of places for people to volunteer. Now we're applying all those rules that we learned in Algebra 1 to our current unit with fractions and their exponents. We're on example number 1 now. We're going to rewrite all of these in the form of x to the power of n, which means I don't have any fraction in the base. I have 1 divided by x to the power of 3/4. I just want x to the power of something. I will do this first one for you. This is using this second rule. If I have a fraction, I can go this direction and make it negative without a fraction. So I'm using rule 2 and saying, okay, this used to be a fraction, but if I make this power 3/4 negative, negative 3/4, it's no longer a fraction. And that's how you answer it. This is x to the power of negative 3/4. So let's do this kind of rapid fire style now. What's the next one? Quiet, raised hand. Beverly.
X to the power of -7.5.
There it is. Next one. Quiet, raised hand. I want to get some more people in because these are kind of the easy rapid fire questions. Someone that still has their card. Lorea, go for it.
X to the power of -2.
It was already negative 2/3, which means a double negative is a, say it, Lorea? There it is, positive 2/3. Good job, Lorea.
Can I attempt the next one?
I'm going to choose on the person with the quiet raised hand, sorry. Sam.
I have a question.
Oh, so it's one of these?
Yeah, sorry.
Yeah.
So for the second one, why would you make it a negative?
So since it was already negative down here in the denominator, you just make it negative again. A double negative is a positive.
No.
Oh, the second one over here?
Yeah, the second one.
So whenever you have something that's positive and I bring this whole thing to the numerator, whenever you switch sides on the top and the bottom, that's why you make it negative. You multiply by -1, essentially. And that's just the rule coming back from up here. If I had something, we started with this right-hand side and I wanted it to go to the left-hand side, I brought this x to the end to the top and made this a negative exponent. And if you have more questions, I can answer them later. Jaden, did you want to do number 4?
I will try it.
Go for it, yeah.
So it's x. Positive 4 over 5.
Positive 4 over 5. That is correct. So those are the answers for the first 4. Make sure you have those answers correct on your own. So when switching the variable between the numerator and denominator, this rule that we've just been dealing with, we switch the what of the exponent? India?
Sign.
The sign of the exponent. So if it was a positive, make it negative. So if it was a negative, make it positive. If it was a positive, make it negative. You just switch the sign. All right, we're on to example number 2. We're using a different rule now. I'm multiplying with the same base. What do I do with the powers? What operation do I do with the powers? Ellery? You add them. Can you help us to add -2 and 1/3? So I now need to add these two. Let me write down my scratch work down here. -2 plus 1/3. How do I do that, Ellery?
Just like 2 and 1/3.
You could make it a mixed fraction. How do I make it an improper fraction?
So you can put -2 over 1, and then you have to have a common denominator, so multiply the left side by 3, so you have -6 over 3 plus 1.
So is it a positive or a negative?
Oh, 'cause it's negative. Wait, yeah, I had it flipped in my head. Negative 5 or
Oh.
negative 5.
There it is, negative 5/3. So your final answer, Ellery, therefore is
Y to the negative 5.
thank you. To review what we just did, because we have the same base and we're multiplying, you can look up here for the rule as well. If you look up here on your notes, I'm adding negative 2 and 1/3. So I'm adding negative 2 and 1/3. As a review of how to do that, we need to have like denominators. So I multiply the top and bottom by 3. Now they have the same denominator of 3. And I added negative 6 and 1 is negative 5. Keep the bottom the same. So the power is negative 5/3. Ask questions. Chewy hood. Then someone try telling me how to do this next one then.
Was the top part sign?
It was, yes. Beverly, walk us through it.
So you have 2 over 5 plus 4 over 1.
Yep, so we're adding these two exponents because I'm multiplying down here. So 2 over 5 plus 4 over 1.
And on the right side, you're gonna multiply by 5 on both top and bottom.
Okay, so our new equation, our new addition problem is,
It's 2 over 5 plus 20 over 5.
which is,
22 over 5.
which means our final answer is,
22 over 5.
careful, don't forget your base.
Oh, y. 22 over 5.
Thank you, there it is. Give me a fist of 5 for at least this last section, where we're adding and you have to deal with fractions. I'm seeing lots of 4s, a few 3s, a few 5s. I would say that the average is about 4 there. Let's go on to the next section. We're on to example number 3. Now we're dividing with same bases. All right, someone walk me through this. How do I do these problems? India, go for it.
You're going to subtract 3/5 and 7/10
3/5 minus 7/10. Why am I subtracting?
because you're
Dividing the expressions.
dividing the expression.
Yeah, because this is division, that means we're subtracting. Okay, walk us through it. How do we subtract?
First, you're gonna for the left fraction, you're gonna multiply the top and bottom by 2, so that it has a common denominator of 10. It will be 6/10 minus 7/10, and that will give you negative 1/10.
Which means our final answer is?
It's gonna be w to the power of negative 1/10.
There it is. Thank you, India. All right, very, very similar problem. Slightly harder because there's a hidden power here. Is there a quiet raised hand that can tell me what this power should be right here? Anyone that sells a card? I'm calling on the same 4 people over and over again. What power should this W be to? W to the power of... Atziri. Thank you. 1. If there is no power, assume it's 1. If there is no index, assume it is 2. So this is going to be another problem. Who can walk us through it? The same people over and over again. All right, Ellery, again, go.
So you're gonna have 1 over 1 minus 1/3.
Okay.
And then to give it a common denominator, you multiply by 3. So you have 3 over 3 minus 1/3. So to give you 2/3. So your final answer should be W to 2/3.
Yep, correct. So again, we're multiplying the top and bottom by 3 over 3, as Ellery said, to get the problem 3 over 3 minus 1 over 3. And she told us that that was 2/3. And say the answer again.
You have W to the power 2.
All right, thank you. All right, we're moving on. To example 4. What am I doing? What operation am I doing with these powers? Am I adding, subtracting, multiplying, dividing? I'm giving that one as kind of like the easy scaffolding question. So I'm going to only let people that have their card answer. So that's between like 5 people now. Someone that still has a card. What operation are we doing with 3/7 and 2/3? Are we adding, subtracting, multiplying, or dividing? It's one of those 4. You have a 25% shot, 25% chance of getting it correct if you have no clue. Come on, someone with the requires hand that has a card. What are you doing with these fractions? I need to get more people participating here. Sam already participated. Sorry, I have to give it to someone with a card. I think you did, yeah.
She asked a question. I asked a question.
Oh, okay. Yeah, go for it. Multiply, thank you. Now someone else with the quiet raised hand. How do we multiply 3/7 and 2/3? It doesn't really matter at this point. We're going to have to just get through this. Let's go for it, Beverly.
You just multiply across.
Multiply straight through. So the numerator is going to be...
It's going to be 6 over 2 over 1. And then it's going to be 2 over 7. Right?
Yep.
If you-
So if we reduce that, so let's come back here. So we'll do our scratch work. 6 over 21 because we multiplied straight through. And you said what again?
2 over 7.
3 divided by 3. 2 over 7. So our final answer is...
A to the power of 2 over 7.
Perfect. And again, you could have cross-canceled too. You see, oh, there's a 3 there and a 3 there. You could have cross-canceled that way. Question, Anna?
Why are we dividing by 3?
We're just trying to reduce that fraction. Reducing the fraction 6 over 21 has a greatest common factor of 3. Yeah, good question. All right. Someone else help me out with the next problem. Go for it, Anna.
So you do 1/4 times 3 over 1, and then you get negative 3 over 4, and you can't divide that, so you just add the 8.
There it is, 8 to the power of negative 3/4. Yeah, the trick there is making sure that you have a denominator of 1, so you know how to multiply those fractions. All right, we're moving on to example number 5. This is where they start getting difficult. Question? Oh, you're going to do it? Yeah, so everything that we've been doing up until this point is the first assignment. Now with example 5 and 6, we're doing the second assignment, which is the harder version of everything. Ellery, walk us through it.
So first, it's like what we were doing yesterday, where it's like z to the 3rd and then 4th. I don't know what to call that, but you put it into the exponential form. So
Okay.
it's going to be 15z to the power of 3/4 over 3z to the 5th. And then you can divide. So that's going to equal 15 divided by 3 is 5, and then you do 3/4 minus 5, which is going to be 4 and 1/4, which is
Yeah, so let's treat that as a separate problem. Let's make sure that everyone is caught up with what Ellery said so far. So there are 2 parts. The first part is getting this into exponential form. This is the top, this is the bottom. The numerator is 3, the denominator is 4, 3/4. Ask a question on that. No, then we must be good. So the next thing is we need to simplify. So I'm going to divide all of the coefficients. 15 divided by 3, that's nearly 5. And then I need to divide the variables. The way that I divide my variables, we've been doing this before. Whenever I divide, I'm subtracting their powers.
we actually had it. Can you go back to the first step? How did you get all that?
Yes, so this 4th root of z to the power of 3, this needs to be rewritten in exponential form. This is going to be the denominator 4. This is going to be the numerator, 3. So it's going to be z to the power of 3/4. That's all we did for the first step.
Okay, sorry,
No,
the
that's
wrong
good.
problem.
That's fine. Other people
Why'd
will
you add
better.
5 as well?
Repeat it louder, please.
Why'd you add all that 5 and all that stuff up top?
So I said, so now we're reducing, right? What's 15 divided by 3, Oscar?
I don't know.
5. There it is. 15 divided by 3 is 5. So we're dividing, right? We're saying 15 divided by 3, we divide. Now I'm dividing z to the power of 3/4 divided by z to the power of 5. And I told you before that whenever we divide, we're doing this rule. Now I'm doing this rule where I'm dividing variables. The bases are the same. Now I'm going to subtract their powers. So I'm coming back down here to the power, or down here to the problem. I'm subtracting these powers. 3/4 minus 5. 3/4 minus 5. That's going to be a side problem that we're going to do. But our answer is going to be something like z to the power of something. We just don't know what that something is. That something is going to come from 3/4 minus 5. We have to do our scratch work, can't pronounce that, down here, and then we're going to come back and fill in the answer. All right. Ask me a question. Otherwise, we're going to turn it back over to Ellery so she can do 3/4 minus 5 for us.
Could you zoom out to 10?
All right, Ellery, it's yours. 3/4 minus 5. What's the next step?
Okay, so put a 1 under 5, and then you need a common denominator. So you're going to multiply 5 over 1 by 4, which is going to leave you with 3/4 minus 1/4, which is going to be equal to negative 17. So your final answer is 5z to the power of negative 17.
Question?
It's not even worth asking.
Why? I'll repeat this process one more time because I know this is difficult. We're using a bunch of properties we haven't used for a while. It's been like a year since we've done Algebra 1. And we're applying this with fractions, which are they're just normally hard for us. So the first step was converting z, or the fourth root of z to the power of 3 into exponential form, z to the power of 3/4. Now that we have this, we're going to simplify the coefficients. 15 divided by 3 was 5. The next step is to divide z to the power of 3/4 divided by z to the power of 5. To do that, I'm really subtracting 3/4 minus 5. 3/4 minus 5, and once we do all the fraction math, we get negative 17/4. That's why it's z to the power of negative 17/4. Ask me a question. Then we're on to our not final problem, we have 2 more, don't we? Okay, so example number 6. Let's do this one. I'll give you guys a hint. We should probably deal with the inside first, simplify the inside, and then apply this power, which is really a cube root, but we can treat it as a power.
Every time I get it, we just swap to something.
Yeah, we're switching all over the place.
I don't like that.
Yeah, I'm sorry, but that's how people learn. If it's easy, that means we're not learning. If it's hard, that means we're learning.
I don't know how to do any of this, so that makes it better.
Let's simplify the inside. Quiet raised hand. This is now going to be turned into the cube root of what? What goes on the inside? India, walk us through it.
So first you have to add the 2 exponents to this plus 1/4, and you on the left side you multiply it by 4 because you have to get the same denominator, and the closest denominator is 20, and so you're going to multiply the other side by 5. You're going to get the exponents to change into 8 over 20 and 5 over 20, which will add to 13 over 20, and that is the exponent of b.
Perfect. We'll pause there and turn it over to someone new after this. Unless you still want it, India. We can give it back to you again if you want it.
Someone else can have it. I've done one.
Okay. So, we're adding these powers because we're multiplying the bases. Whenever you multiply the bases, you add the powers. This is us doing the work for adding the powers. Just so I can figure out where everyone in the class is, how comfortable are we adding fractions with unlike denominators? How comfortable are we doing these types of problems starting right here? Adding 2/5 and 1/4. Give me a fist of 5. How well can we do that? I'm seeing a 5, 3, 5. What do you got, Chewy? 3, 4, 3, 4, 3. Okay, so we're not as high as I would like us to be, but we'll have lots of practice of this. All right, so now we're at this step. I need to now convert this into exponential form. It's in radical form because I have this radical symbol. It's a square root symbol, also known as a radical symbol. How do I get rid of the radical symbol and turn this into an exponential problem? Who can do that for us?
Can you stack fractions?
You can. And stacking fractions looks like this, right? I have a power to the power. I'm stacking those powers.
I can try.
Go for it.
Okay, so you would have, like, in parentheses, b to the power of 13 over 20, and then on the outside of the parentheses would be the 3.
It's not
Or-
3, it's
1/3.
1/3. There it is. I'm going to pause here. This is just from yesterday. We learned this yesterday. So sorry, really. That's probably why this is not really.
Yeah, I'm like, well, what the
Whenever I do a cube root, the cube root means I'm taking it to the power of 1/3. And now I'm going to go back and use my new rule. If I have a power to the power, I'm really multiplying these through.
Like, I understand that. I just don't know how you got the one.
Yeah, and that'll come from watching the video from yesterday. If you watch that video, it will make more sense. I hope it will. All right, and who can do this multiplication for me to finish off this problem? Go for it, Beverly.
13b to the power of 13 over
60. There it is. Final answer. B to the power of 13 over 60. Make sure you know how to do this, or at least have it in your notes so you can review it tonight. You might not have it down right now because it's confusing. The way that you will get it down is by going through these problems again. Looking at your problem, looking at your homework, and seeing how does this relate to the problem that we did on the homework. I'm trying to do as many different types of problems on this notes so you'll have a good reference for the homework. And we're on to our final problem. I can zoom out so you can still see the other one. Here's our final problem. The first rule that I'm going to use is this one right here, the first distribute rule, right here. I have a coefficient and I have a variable, both of them to some power. Someone do the first step. Question, yeah.
Like, in the one before and then in this one too, it says rewrite the expression in the form like k times c to the n. But in the one before, that's not what it ended up looking like.
Yeah, that's my bad. I should have put a number here to make it even harder, like 27, but I didn't. I made it even easier, so you can ignore that part of it. This one does have a k in front of it, though. All right, we have such little time. I'm going to walk you guys through this one. All right, this 1/3 is going to be applied both to the 27 and to this 7th root of c to the power of 5. So I'm going to do one thing. I'm going to change this into exponential form first. So I still have the 27. I haven't touched it. This is now c to the power of 5/7. C to the power of 5/7. All of this to the power of 1/3. I only changed this 7th root of c to the power of 5 into c to the power of 5/7. That's the first change that I made. That's from yesterday. Next, I'm now going to apply that rule that I just talked about where I'm going to make this power go and apply it. I'm going to multiply it to this power, and I'm going to multiply it to this power. So I now have 27 to the 1/3 times c, and this is going to be c to the 5/7. All of that to the power of 1/3. Again, I'm really distributing this power of 1/3 into both of these two terms. Or I should say both of the parts of this one term. All right. Our next step, I'm going to come down here, zoom out a little bit, to this next line. To the power of 1/3 is the same thing as a cube root. So this 27 to the power of 1/3 is now the cube root of 27. Does anyone see 27 up there on the wall that Arrow just made a few weeks ago? Does anyone see a 27 up there?
Where?
On this wall up here on the cabinets, top rightish area?
No.
Does anyone see a 27?
What's under there?
Yeah.
What is the cube root of 27? What is the length of that cube?
All I see is fuzziness.
3?
3. The cube root of 27 is 3. So that's how you find that one. Again, if you go to your calculator, it works as well. If I do 27 to the power of, and in parentheses, 1/3, come on, computer, it's 3. If you don't know how to do this, your calculator will be able to do it for you. And then finally, I'm going to multiply these powers together. 5 times 1 is 5. So this is times c to the power of 5. And on the bottom, I have 21. My final answer is 3c to the power of 5 over 21. So 21 came from 7 times 3. 7 times 3 is 21 for the denominator. Again, I'm multiplying straight through.